Some of today should be review. Some will be a little bit further review than others. And of course, some of you won't pay attention and put these notes in the wrong spot. This obviously right here is quadratic formula. I don't think you are anywhere near as impressed by the quadratic formula as you should be. Quadratic functions are the only functions that have one formula that solves every single one of them. You get to cubic, there is not one formula that solves them all. And that's such a tricky proof, it finally actually was just proven maybe 10 years ago. And so keep in mind that that's pretty impressive, that one formula right there solves any quadratic equation you can be given. Realize that's x squared and then other stuff. It'll solve them all. You can't get above x squared, but it will solve those. But please notice that we are doing the second example and not the first one. So you might be very confused if you look at your notes and it says to do it by completing a square and you have quadratic formula in the notes. And then when it says to do quadratic formula, you have completing the square. That could be very confusing. So please realize we are on the one down at the bottom of your page. Something you might want to know about quadratic formula is that you want your equation to equal 0 if you're going to try quadratic formula. Does that particular equation right there equal 0? So do you just subtract the negative 11 and then it equals 0? Unfortunately, you could do that, but then you're just going to get the wrong answer because you're solving a different problem at that point. And so what we have to do is make sure that everything equals 0. And so the simplest thing to do, add 11 to both sides, and then we have x squared minus 10x plus 21 equals 0. The key is what I have in blue the same thing as the original problem? It is. If I just subtract, or if I just erase the negative 11, it's not the same thing anymore. It's not the same problem. And what you need to know is basically because over here we've got these A's, B's, and C's all over the place. A is the coefficient of what's called the quadratic term. And what in this case, what is A? It is 1. B is the coefficient of the linear term is what it's called. And that is negative 10. C, very cleverly, is the constant, which is the number without a variable on it, which is 21 in this case. So if we substitute, take the opposite of B. Well, B is negative 10. So if I take the opposite, it's positive 10. Now it says to take whatever B is, which is negative 10, and square it. Right? Because it said put the. And minus 4 times whatever A is, 1, times whatever C is, 21. Divided by 2 times whatever A is. Any questions how I substituted? Unfortunately, with quadratic formula, there's a lot of places you can make a mistake. It is great that it works for every single quadratic, but a lot of places to possibly mess up. Order of operation tells us a lot here. Tells us that that division bar is a grouping symbol. So do the top, take care of it, then deal with the bottom, take care of it, then divide. But another grouping symbol is the radical. So basically it says do anything inside the radical first. But once you get inside the radical, there's multiplying, there's squaring. And so you have to keep it all straight. So if we do this, we'll keep going. It's 10 plus or minus the square root. If you type in negative 10 and square it, and if you do it improperly on your calculator, it will tell you negative 100. Okay? So make sure that you do that properly. If you want to actually take negative 10 and square it, make sure you actually just type it in that way. If you type in negative 10 caret 2 or something like that, it's going to give you negative 100. Because it squares the 10 and slaps a negative 1 on it. And negative 10 squared, of course, is 100. Where a lot of people mess up is this last part. Right here. So you need to come up with a strategy that's going to work for you. I look at it this way. I pretty much figure out what's the sign going to be first. So I'm taking a negative 4 times a positive 1 times a positive 21. So overall, what's the sign going to be? Negative, right? The reason I do it that way is now I don't even have to look at the signs anymore, right? I know it's going to end up negative. So then I can just take 4 times 1 times 21 and not even worry about what sign does it have on it. And what is that, 84? All over. And it is okay to do the bottom side, but it's just 2, right? And so here we go, x equals 10 plus or minus the square root. Now you can actually do that work inside the square root, which is what, 16 over 2. Now 16 happens to be a perfect square, right, which is nice. Is there any guarantee that there'll be a perfect square in that radical? No, there's not, right? And so then you just have to clean that up if there isn't a nice number in there. I really don't want decimals. So 10 plus or minus. Well, what is the square root of 64? Right, but well, that's kind of a weird way to look at things. There's a plus minus symbol in there. So what you do is you just go ahead and you say, well, let's do the 2 problems separately. 10 plus 4 is 14. Then divide that by 2, you get 7, right? Then you do 10 minus 4. Well, that's 6. Divided by 2 is 3. There. Now, based on information that you've gotten earlier this year, what can you tell me about those 2 values there? Again, this is trying to put things together. We did this earlier this year. Agreed it's quadratic? If you graph it, what are you going to have? What's the shape called? Parabola. This parabola will open up. How do I know that? Positive x squared, right? So what's going to happen at 7 and 3? It's going to hit the, not the hole, the, not asymptotes, this isn't rational, x-axis. Okay? So that's where it's going to hit the x-axis. So we know at least this much now, that if I go to graph this at positive 7 and at positive 3, we know it opens up. We know it does something like that. So you just found the roots or zeros. That's what those are called. And the fact that it came out to integers like that, could we have key number factored? Would it have worked? No. If it comes out to rational numbers, key number would have worked. Does key number always work? No. Does quadratic always work? Every time. Could you possibly make a arithmetic error? You could, but quadratic itself always works. Now you may notice I've given you the exact same problem. We're going to solve the exact same problem a different way. You might wonder why. If quadratic always works, why use this? Because this, believe it or not, is where quadratic came from. This is always how it used to be done. But then somebody knows, hey, I'm doing the same thing over and over again. There's got to be a formula for this. And then they did some proofs and things like that. But again, that took a long time. When you want to complete the square, what you're going to do is on the left side, you're going to make what's called a perfect square trinomial. Basically, what it boils down to is you are going to choose the constant, and you're going to make that constant the number you want it to be. But do you agree that I already have a constant on the left side? It's a 10. That may or may not be the constant I want it to be. So I need to get rid of it. And there's only one way to get rid of that constant. And that is subtract 10. X squared minus 10x. Put plus a blank. That might refresh some of your memories. Equals. Well, what is actually on the right side now? Yeah, 21 and happens to be negative, right? Now, our goal here is to decide that number. And we're going to decide that number in a very, very particular way. But do you agree I'm going to add some constant to the left? So I better add the same thing to the right, or I've changed the problem, correct? So we better put plus that same blank over there. Now you could choose 7 as your constant, but you'd be wrong. Because we're going to try and make that, because you agree there's going to be 3 terms on the left That's a trinomial, right? I want to make that basically a perfect square trinomial, or some people just call it a perfect trinomial. And we're going to make it, like I said, in a very particular way. The first thing that you want to check if you're completing the square is my quadratic coefficient 1? Is it? Yes. So you might want to write that off to the side, something very important, that leading coefficient or quadratic coefficient has to be 1. And another thing you might want to write is we're trying to figure out the constant. If that happens to be 1, here is how you figure out that constant. And I would suggest you write in this little work that I'm showing you. You take that number right there, which is the linear term, and you take half of it. What is half of negative 10? Negative 5. But negative 5 is not the number I'm going to put up there in that blank. Before I put that number up in that blank, I'm going to square it. So negative 5 squared is? So is it okay for me to put plus a blank? Is it always going to be plus a blank? Because what do I do to that number before I put it into the blank? So is it always going to be positive? Yeah, so you're going to say plus a blank. So that blank is 25, so that one better also be 25. Now, the next thing I'm going to do, you can choose to write down or not. It may save you some time if you come back to your notes. Really, at this point, we're almost done, but I'm going to show you something that's going to take a little bit longer than what it should. I'm going to forget about that right side for right now, and I'm going to just go over here. Don't put the arrows in like I am. Maybe just follow along for now and then decide if you would like to write it down or not. Or maybe you'll paraphrase it or something. I can guarantee to you that that will key number factor. And I can guarantee to you I already know the answer because of how we did this. So let's just try it. Multiply to be 25. Add to be. Do such numbers exist? So then we're going to go here, x squared. This is going to turn into negative 5x minus 5x plus 25, right? Here's key number in. Can I get x minus 5 over there? What do I got to take out, though? Negative 5. So degree, it's x minus 5 and x minus 5, otherwise known as x minus 5. Oh, look at that. It's a perfect square. But we made it a perfect square by how we figured out that constant. That's why I told you this right here, I am guaranteeing to you, if you follow my directions, you will make a perfect square trinomial every time. Which means at this point, instead of doing all that factoring every time, let's face it, that's a pain in the butt. You can just jump right to this step and know that that's going to happen. It's a perfect square. And I can even tell you how to find out what goes right there. That's why you write down all of this work, because that number will always be cleverly hidden right there. Every time, if you complete the square. But do you agree that's only the left side? What does the right side equal? What's it equal? 4. So we have changed this equation considerably, right? Can I erase the key number factoring? See, you really don't have to do that every time because I just showed you you made it that way. But some people don't believe me, and then some people want to write it down, and so that's fine. Well, apparently that's not going to work today. Or not. So we'll just erase it old school. There we go. Now, right here, we have an equation But don't we already know the answers? Aren't the answers supposed to be that? It's the same problem. Shouldn't the answers be the same? Now I realize this one's taking a while because I have to explain it, right? Really, if I gave you this again, you'd get to this step fairly quick, right? I mean, it doesn't take that long, really. And so what we're going to do is we're going to solve. So what's probably the first thing we want to get rid of? The square. How do you get rid of it? Square root. Because it housifies, right? X minus 5 equals, be careful, plus or minus 2. Very good. How are we going to solve this then? Add 5. So x is apparently a positive 2 plus 5 and a negative 2 plus 5. Positive 2 plus 5 is? Negative 2 plus 5 is? Look at that. This is how it always used to be done. This will always work as long as the leading coefficient is 1. What do you do if it's not? Well, you make it 1, which means you might have some horrible fractions, which is at the point where somebody said, you know what, there's got to be an easier way, and they came up with quadratic. But the reason this one is very helpful is it gives you more information. Do we still have the 2 roots? This is still a parabola, right? This right here, if I move the 4 over, right, if I subtract the 4 over to the other side, have you seen stuff like this? Yeah, and you've been graphing stuff like that. Can I figure out where the vertex is based on this equation? You move over to the right, 5 and down 4. So not only do you have the roots now at 7 and 3, you go over 5 and down 4, you've got exactly, that's 3 pretty important bits of information about a parabola. And you've got them all within the span of 3 minutes. Okay. Notice how I did have to get them on the same side of the equal sign though. So a lot of information there. Any questions about either type? I do want you to be fairly good at both. Because remember, quadratic really came from this. So, like that 2 right there that's on the bottom, you can almost envision where that ends up in the quadratic formula. Maybe, maybe not. I can. So we're going to do this one by completing the square, and then we'll use a quadratic formula. But this one's going to take some work. What do you say? Why not? That does matter. Yeah, the 1's not the leading coefficient, so that's a problem. Now, if we're going to do completing the square, here's the 2 biggest difference. Completing the square, you want to pick the constant. So is it probably going to equal 0? Probably not, right? In quadratic, it has to equal 0 to even start. Okay. So if I wanted to do quadratic, I would basically make the y a 0, because that's what you want to know anyways. Really? Because if you're on the x-axis, isn't the y value 0? And so if you do quadratic, that's how you're going to want to start it. But I'm assuming you could all do quadratic, so I'm not so worried about that. So let's do completing the square. So we'll put 0 in anyways. Now I've also kind of flipped things around on you here a little bit to see if you can handle it. We'll find out soon enough. What do I want to determine if I'm doing completing the square? I want to make the constant. Well, what's in the constant spot right now? Negative 2, right? Do I know if negative 2 is right or not? Well, probably not. So let's get that thing out of there. How do you get it out of there? Add 2, you do it to both sides. All right? So we've got a 2, and I'm going to leave a space there. You probably know why, right? Equals 3x squared plus x, right? I can put the plus blanks in if you want, but we still can't do completing the square. I've given you two checklists, basically. We want to do the constant check, but what are you going to do? Just erase it? Unfortunately, yeah, divide everything by 3. Don't worry about your blanks, though. Don't divide them by 3. All right, so if I divide 3 by 3, I get 1, right? If I divide this by 3, you know what? I'm just going to rewrite it. Forget it. Divide this by 3. 2/3, right? Plus blank. Not blank divided by 3. Don't do that. Equals x squared plus 1/3 x. Very good. Plus blank. So our two checklists are, we want to make the constant. We're about to. And the leading coefficient has to be 1. And what we're trying to do this time, it's the right side that's going to be a trinomial, correct? And we're going to try and make it a perfect trinomial. And we're going to do it the same way. So what do I have to do? There's your, and then 1/3 comes down here. But what do I have to do to that? Half of it, right? Well, what is half? Well, that's just multiplying, right? So it's 1/6. Everybody see the 1/6 there? Is 1/6, it's very easy to do this, is 1/6 what goes in the blank. Especially when you have fractions, it's very easy, right? It's very simple to just throw that in there. But unfortunately, what do I have to do to that? I have to, very good, it's 1/36. When you have fractions squaring, we just square the top, square the bottom. So square 1, you get 1. Square the bottom, you get 36. What goes over here then? 36. That was a pretty nice 6. Any questions so far? I'm not saying this is pretty. I'm just saying this is how you do it. Now, what did I call that right side again now? What is it? Trinomial. It's a trinomial. It's more than that. Perfect square trinomial. Now, is it okay if you feel like factoring that, you go right ahead. You factor that, it will happen. Good luck finding the numbers that multiply to give you 1/36 and add to give you 1/3. I'm guessing it's 1/6 and 1/6. Just wild out there guess. Okay? Because remember, if you have this, you can skip all that factoring stuff. If you made it right, it's a perfect square. And what goes there? 1/6, and it's a positive, right? So plus 1/6. Any questions how I went from the black rectangular shape to x plus 1/6 squared? Again, I'm avoiding all that factoring. Okay? I'm having you make that problem that way. Well, what about this, though? We've got to figure out what this side is. Well, this is 1/36. What should I probably do on this left side? Got to figure out what it is. So get a common denominator. So what do I have to multiply by? Yeah, 12, right? Now, is it okay at any point in any problem to take any bit of it times 1? Yeah, right? You're not changing it. You can do anything. And all I'm doing is taking 2/3 times 1. Right? It just happens to look like 12 over 12. But that's okay. And so we got 36 on the bottom. What's on top? 24? So what does this side equal? 25 over, believe it or not, those are better numbers than they need to be. Ah, they are both perfect squares. Oh, this is lovely. They don't have to be, by the way. Well, now what? Square root. Sound effects optional when you do it. And if you're going to do sound effects, at least make them good ones. Now, hopefully you're not going to that calculator to find out the square root of 25 over 36. Square root of top, is 5. Square root of the bottom is. But what is wrong with what I have written? Plus or minus which one? 5, 6. Yep. We're almost there. Now what? Yep, subtract the 1/6. So we'll put minus 1/6 down here. The nice thing is almost all the time with completing the square, it gives you a common denominator at that step. That's kind of nice. It doesn't have to, right? So it's a positive 5/6 minus 1/6 is 4/6, otherwise known as 2/3. So x equals 2/3. Or, yes, or, very good word. Negative 5/6 minus 1/6 is negative 6/6, otherwise known as negative 1. Yes? So what did you do now? Did you get decimals? What did you do then? Ah, you used the fraction button. So I'm assuming you had 25/36 at some point, though. That's fine. Well, you kind of did. You just used the calculator to do it. Yeah. But here's where people run into trouble with me. They start throwing decimals in there. Do not do that. Some of these answers are not going to be pretty. Do not put decimals in there. Okay. I'll come back to this one in a second and show you what one would look like that might not be so pretty. Okay. Again, I'm assuming you can all do it quadratic, and guess what? You get the same answers. But what you don't get from quadratic is the vertex, which comes from right here. Good luck finding that vertex on your own. Left 1/6 and down 25/36. Yeah. One very quick thing to talk about is called the discriminant. It comes from quadratic. It is b squared minus 4ac. It's the stuff that's inside the radical. I hope you agree with me that if you had something like, say, let's say you did all that work, and 14 was that number that you had inside the radical. So what I'm saying is you've done all of this work here, and instead of 16, you got a 14. You agree that is actually something I can take the square root of, though, right? It's a number, right? It exists. But there is a plus minus out front, right? In quadratic. So what here is it saying is if that is greater than 0, is this greater than 0? Or in other words, if it's positive, you're going to get 2 answers. Did that happen back here? Did I get 2 answers? I did. There they are. If we would have done this one quadratic, would we have gotten 2 answers? Yeah. Okay. What if that number in there, so what is this one saying? That it's, so can it be anything other than 0? Well, is that something that can happen? And it's plus minus out front still, right? Well, what is the square root of 0? So wait a minute. If I was back here and put a 0 in here, if I add 0 or subtract 0, is that any different? So really it would have just been 10 over 2, right? How many answers would you have gotten? 1. So that's why here it's saying if it equals 0, you only get 1 answer. So here there are 2 real, 1 real, and here's everybody's favorite. What's that really saying? Less than 0. So in other words, negative. Negative square roots leads you to imaginaries. Okay, so you can say either 2 imaginary or 0 real. Are there still technically answers to that? Yeah, they're just unfortunately imaginary. but none of them will be real in that case. Imaginary numbers come from complex analysis and complex roots. There is actually an imaginary axis, which creates fractals. It's like those Sierpinski triangles we did, where if you zoom in, it looks the same as if you were all the way out. That's a fractal. Okay. Now, are there any questions on discriminant? Nope. Let's take a look at this real quick. Hey, let's say you were doing this problem and unfortunately you had something like this. This can happen. And let's just make that number over there better. There we go. Let's say you were going along and this is what happened with completing the square. This is a for instance for you. Maybe throw it somewhere off to the side or something so you know how to deal with it. You could still solve. You would take square root, right? Cancels. What do you do with that, though? What is the square root of 23? I know it's a little less than 5, but that's about all I know. Is it a perfect square? Is the denominator a perfect square? Let's face it, that denominator, we kind of made that denominator, right? I mean, when we did the problem, it came from us. We made it a perfect square on purpose. So the denominator will normally go. So the square root of 23, yeah, that's, what are you going to do? But that, I can take the square root of it is 6, and this is plus minus. And then just subtract the 1 over. Negative 1 plus minus the square root of 23 all divided by 6. Do you end up with answers similar to that in quadratic from time to time? Yeah. And just leave it like that. That's the best you can do. I don't want decimals. Any questions? Again, you got completing the square, quadratic formula, and discriminant are what we learned today, or reviewed, I would say. No questions?